Hi, my name is Michael Bowling and I am a geometry teacher for Harmony Science Academy, Houston High Campus. Today we are going to talk about creating linear functions from a pattern. Our students will create a table, graph, and formula to represent a function. They will explore the relationship between the variables and they will be able to determine slope and the y-intercept from a table. They'll also be able to transfer between different representations, such as table to graph, graph to table, table to formula, formula to table. Materials we'll be using for this lesson include popsicle sticks, some graph paper, pen and pencil, something to write with. So here's your task. We'll start with create a bridge with a base beam of 1. Great. How many popsicle sticks have you used?
3.
Very good. Now create a bridge with a base length of 2.
Done.
How many popsicle sticks have you used?
7.
7, okay. And finally, build a bridge with a base length of 3. How many popsicle sticks have we used?
11.
Fantastic. How many sticks would you need to build a bridge with a base of 10?
Well, we don't know that yet.
All right, let's see if we can figure out a way to figure that out. Okay, so we've had 3 different bridges so far, and we need to figure out what a bridge with a base of 10 is going to have in terms of popsicle sticks. So I'm having a hard time keeping track of all of our numbers. How can we organize what we've come up with so far?
Well, aside from actually counting one by one, we could make a graph and organize the data that way.
Okay, if we wanted to make a graph.
Oh,
Or a table.
table.
Okay, let's go with a table. Show me what a table would look like.
So we'll have 2 columns, and since we use 3 base sticks, we could have 3 rows. 1 for each base stick that we use.
Okay. So what's your first column represent, Ben?
The first column will represent the number of base sticks,
Okay.
and the second column will represent the amount of sticks that we used to make that.
Good idea. Okay, so when we used 1 base length, how many sticks did we use total?
3.
Okay, and when we had 2 base sticks, we used
7.
7, and when we had 3 base sticks, we had
11.
11. Okay, so now let's use that to find out whether there's a pattern going on here. Each time the base level increases by 1, what happens to the total number of sticks?
Increases by 4.
Okay, so can we use that to figure out how many we're going to need when we get to 10 sticks in the base?
Yes.
Okay, show me what that looks like.
Well, we could and 2.
Okay, it looks like we're going to need some more information before we get there. Let's say we continue the table as the pattern. Instead of skipping straight from 3, let's go
4.
4, 5. Yeah, let's follow the pattern out till we get to 10.
4 plus 11 plus 4 is we go to 19.
And then when we get to 6, 19 plus 4, 23, 7, 23 plus 4, which is
Matt ran out of room.
Yeah, I love it.
and then when we get to 8, 27 plus 4, which is 31. When we get to 9, 31 plus 4, which is 35. And when we get to 10, 35 plus 4, which is 39.
All right, so for 10, we're thinking 39 total sticks. Good. Now, we're talking about linear equations. How can I tell whether or not this makes a linear equation? What does that even mean, linear equation?
We don't know.
Okay, well let's break it down. The word linear. What would be the root of the word linear?
Line?
Line.
Line. Okay, do those numbers look like a line?
Not really.
Not so far.
Okay, well how could we make them look more like a line?
Make it into a graph.
Alright, let's try making that into a graph. Okay, now that we've seen what we can do with the base of 1, base of 2, base of 3, let's start keeping track of where we got. So, you guys came up with a great idea of making a table. I like it. Let's see what that looks like.
Well,
So, we're going to need how many columns?
2.
2. And the left column is going to be
about the base stacks, the base sticks.
number of sticks in the base, okay. And the second column?
The total amount of sticks we ended up using.
Okay, so let's go through it. 1 stick was a total number of,
3.
okay, 2,
2
7.
was 7.
3,
11.
okay, 4.
15.
All right, so let's keep going with that and see what happens. So each time you go down, what are we adding to the previous number?
4.
Okay. What'd you get for 10 base sticks? How many total sticks do I need to build that bridge?
39.
39. Okay, good stuff. Today's topic is about linear functions. Does that look like a line?
No.
Nope.
The numbers don't make a line? Okay, how can I make them look like a line?
You can plug it into a graph.
Plug it into a graph? Want to draw these?
Yeah.
All right, sure. Let's try that out. So I will go ahead and give you guys what you gave me. We have 4, 5, 6, 7, 8, 9, 10, and you guys gave me what? 3, 7, 11, 15, 19, 23, 27, 31, 34, 5, and 39. So in order for me to turn this into a graph, what are each of these pairs of numbers? How's that going to work?
We can make the base length the x-axis, and the total number of sticks the y-axis.
Okay, great. So then the pair 1, 3, what would that look like on our graph?
It will be in the. It will be above the 1 by 3, up 3.
All right, so here is a graph. You've got a graph. Ben, you've got the points. Let's put those points on the graph. So I need to talk about it. I've got 2 different ways I can go. I can go right or left. I can go up or down. So let's talk about going right. Which of those columns do we want to put on that?
The amount of sticks we used for the base.
Base, okay.
On the x-axis.
Let's put the base down here. That means that we'll put, what's the other
Total
one?
sticks.
Total sticks up here. Okay, total sticks. Okay, what was our first
Our first base
Set.
stick was
1? Okay, so we went over
3.
base 1 and how many sticks?
1. We used
3.
3.
3 sticks, okay. And then for,
Our second one, we used 2 base sticks
Yeah.
and 7 total sticks.
5, 6, 7, okay.
For our third one, we used 3 base sticks and 11 total sticks.
1, 2, 3, and 10, 11. Matt, how you doing over there? You still got room?
No.
Okay, well, our limitations are there. Let's see if we see anything happening here. How far is it from this point to that point? How could I get from here to there? Telling, let's say we're talking to a 7-year-old. Tell the 7-year-old to start from here. How does he get to the next one?
Well, the 7-year-old will want to go up 4 and to the right 1.
Okay, so he went up 4 and to the right 1. What about from the second dot to the third dot?
Same.
would want to do
It would
the
have to
same
go up 4 to the side 1.
Okay, so that's the same. Well, I got more room here. Let's keep going. What's the next point on your, what's the next set of numbers you
It would
got?
be 4 on the x and 15 on the y.
4, 15. Does that follow our pattern?
Yes, sir.
Okay, good. So it looks like I could connect these. Let's try that out, see if we did what we thought we would do. Now does my data look like a line?
Yes, sir.
Yes.
I think we're doing pretty good. So this concept here, we're talking about 4 up and over 1. This is what we call the slope of the line. It gives us an idea of how these points are all related to one another. There's another feature we see here. This is crossing this part down here. How do I know exactly where this is going to cross my axis? How can I figure that out?
Well, since we're going 4 up and 1 to the right, we could do it backwards and just go 4 down and 1 to the left.
Okay, let's try that. So if I started at 3 and I go down 4, 1, 2, 3, 4, and over 1.
I got 0, -1.
Okay, so now we have this 0, -1. Now that's crossing the y-axis. We call that the y-intercept. And that's another important part of how we get from your part, the patterns, to a mathematical equation, which we're going to get to. So now that we've got this, let's talk about for a second what's real and what's imaginary. Okay, we're talking about bridge pieces. Does this make sense to bridge pieces?
No.
Sir.
What's the least number of bridge pieces I can have?
3.
1.
3 to make 1.
3.
What if I have no bridge? How many pieces do I have?
0.
0.
Is that possible? Can I have no bridge?
You can't have no bridge.
Have you seen a bridge in here? How many bridges do I have in here?
None.
None.
None. So 0 is a possible thing, but we're okay with this. We're not okay with that. That's important. So this is what we call the domain and the range. The domain tells me how many numbers I can have from start to finish in a certain direction. In this case, it's the number of our base. So least number of pieces I can have sitting on a truck is how many?
0.
0. I agree. How many pieces, what's the maximum I can build a bridge out of? 100? 200? 300?
It could go on.
Does it ever stop?
No.
No? Okay, so the limit for that is no limit. It goes on to infinity. Interesting. What about the up and down? So we have this -1. Is that actually possible in our
No.
scenario? No. What's the lowest I can have on the up and down?
0.
0 again? All right. So our domain and we're talking about range now. From 0 to, when does that stop? High end. Infinity. All right. Good stuff. Okay, great. Now we've covered a lot of important concepts here. We're going to use this information, this pattern, to figure out our next question. How many sticks does it take to build a bridge with a base of 100? Okay, so let's talk about how we can get from 1 to the number 3, just mathematically speaking. Use an operation and get me from 1 to 3. What do you think?
2. We add 2.
Add 2. All right, let's do that. 1 plus 2 is 3. Nice. What's 2 plus 2?
4.
4.
What do I needed?
7.
Doesn't equal 7. Okay. Well, I'll tell you what. When we used the graph, we found a slope of 4. Let's see how we could use the number 4 starting from 1 to get to 3. What if I multiplied my 4 times my 1? What would I get?
You'll get
4.
4.
We would get 4. What do I need to get?
3.
Okay, so how do I get there from 4?
You'd subtract 1.
All right. Let's see if that works again for our second base. If I have a base of 2
Times 4.
times 4
Minus 1.
is
So 4
7.
times 2 is 8, minus 1 is 7.
7. That does work. Okay. Let's try it for a bigger number. What about 6?
4 times 6 is 24. Minus 1 is 23. That's the number.
Does work out. So look at that. Every time we've got this, let's generalize this. We're using what variable in the left column?
The baseline.
Base thing.
Okay, so L, we'll call that L. And this, what's a good
We could say T. for
T? Okay, let's call it T. So if I say 4 times T minus the 1 should equal,
It should be 4 times
4 times L.
4 times L.
okay. 4 times
trying to
L
look for the total.
minus 1 equals
T.
T. Okay, that looks good. So if I have it generalized like this, how many sticks would I need to get a base of 100?
Well,
Okay, so 4 times 100.
it minus 1, which equals 399.
That's a lot of popsicle sticks. I don't have enough, so. All right, next time we'll talk about how we can use graphing calculators and other forms of equations. Thanks for watching.
Are we done?
I'm done.
You gotta be kidding. Really?
Yeah.
Why not? Do you want, I mean, what else do you, so, okay guys, so you came up with the equation that 4 times the length of the base minus 1 is going to equal the number of total sticks. So we used that to calculate how many total sticks we would need if we multiplied 100 base sticks. We came up with a total number of 399 total sticks. Now in the math world we would have substituted L for a generic X, and we would represent 399 as our Y, which is the other coordinate. Together X and Y would give us specific points. So thank you guys for your hard work today. We appreciate it. And thank you guys for watching. We'll see you next time.